So we're going to revise over the networking unit, and we'll start off with a wee bit of revision of things that you hopefully remember from standard grade. And just that a definition of a network is where we have two or more computers that are connected together to allow them to communicate, to allow them to share information between them. We had a standalone computer system that is not part of a network, and I think you'd struggle to find any standalone computers nowadays because everything's networked wirelessly and so on. Other revision from standard grade, if you remember, we spoke about LANs, which is a local area network covering a small area like a building or a school. Even your home network will be LAN, and it will be connected up using different transmission media. And with these we typically get high bandwidths, which is a high data transfer rate of quite high speeds. Other things we need to remember about LANs is the different transmission media that we can use. So we get optical fibre, you can have wireless transmission, and we're going to come back and talk about different types of wireless transmission in this unit as well. And we also have copper wire. And now we're starting to get loads of wireless hotspots all over the place. And if you think of any time you're shopping in Glasgow, there's several covering the full city almost that are operated by BT that you have to pay for as well. Some of the simple uses of LANs, if you just think of the things we do in school, we have the ability to share data. So we have the RM shared area, which is technically a client server, where we have our files in a server and everyone can access them at the same time. You can share peripherals, so we all have access to a printer, and indeed several of the rooms in the school can print to printers in rooms that are in opposite ends of the school as well, going through print servers. And internal email service, that everyone in school has their own unique email address that we can communicate, which is internal to the school and can be linked up to external as well. So, quick question, what is the name of the small piece of hardware that you need to connect up? And hopefully remember that that's a network interface card, an NIC, which is a small circuit board that allows computer systems to interface with networks to allow them to communicate, and they usually come built in as standard now. WANs, wide area networks, definition is that they cover a larger area like a city, and the course actually still includes questions on dial-up, which I'm sure some of you have never even heard of before, up to the crazy speeds we're starting to get with broadband now. And I've only got 20 megabits per second on here. It's probably even faster than that, and I keep reading about new trials that are going on with 100 megabits per second bandwidths coming down strands of optical fibre the width of a hair, so it's only going to get faster and faster and faster. Some of the transmission media we use in a WAN: satellites, microwaves, optical fibre. And some uses of a WAN: we can data share globally. If you think about different companies are spread all over the world, just thinking about America, the amount of different car rental places that exist across there, across the UK, all the different Asda stores that we have that are all connected up in some form of a WAN so they can communicate and share data with one another. The ability to email across the globe, communicate directly with loads of other peoples via video conferencing as well. Which brings us on to client server, which is again a wee bit of revision from standard grade as well. And you need to know a good definition of client server, and if you try and describe the setup we have in school, where we've got loads of client machines, we have literally hundreds of computer systems which are all networked together via our different servers that we have, and we need to know some of the uses of the different servers that we have. So we have, for instance, the print server, which job is to store and queue the data sent that people request to print, and queue that up and send it out to the printers. The file servers, which if you look at your allocations, you'll notice that you've got a certain limit of data that you can store on the file servers, and we have servers specifically set aside for storing files in a shared area, which gives us more data to store, and web servers as well, and we're going to have to look at those functions a bit more in depth of all of these servers. So some of the advantages of client servers, again, try and picture in school, the first things we need to do is we need to log in. When you started in the first year, you were given an account, and there's certain areas you can't access in schools. So some of the advantages are, the first one is that it's more secure, because every user has a specific unique username and password that they need to log in with. Every account, we can change the levels of access on there to give more security. For instance, there's a shared area that's specifically for teachers that pupils can't access, and even within that there's different areas that teachers can't access. For instance, the computing teachers can't access the history shared area, and so on. As well as that, we have flexible access. Because your files aren't saved locally on a machine, you can log into any machine, and the file server would allow you to download your files locally to that computer. Workgroup usage is something we don't really make a lot of use of, but maybe in larger companies, if they are working on a project together, they'll all be working on the exact same project at the same time, so editing the same file essentially. And one we've already covered, that at the school we have 21 machines in this class and a couple of printers that we can all print to. There are some disadvantages. I'm sure you've been in school before when the servers are down. So for instance, the web server being down, then no one can access the internet. The file servers have crashed before and nobody can manage to log in and retrieve their files. And one other disadvantage is it's quite expensive to set it up, because it requires expensive file and print servers. It can require different operating systems to set up and install it and maintain it, so there's a lot of ongoing costs with it as well. So we're going to have a look at the different network topologies that you need to be able to explain and draw and label the diagram. So the first one we're going to look at is the bus topology, and this is a diagram for the bus topology, and you should get used to labeling it. So always label the channel and the nodes, and you can see here what we have is the main channel connected up and meeting these two terminals at the end. Now if you picture a message broadcast on this network would travel around on the main bus, and it actually gets sent across to every node that it comes to. Now it's not a very robust network, in that if this main channel is disrupted or is damaged in any way or malfunctioning, then no data can be sent. But an advantage of the bus topology is that if any peripheral nodes are down or some way damaged in the network and not communicating, then it's going to have no effect in the overall network. If you just picture each of these nodes as a bus stop, if you take away a bus stop when a bus is out driving, the only problem is it can't stop there anymore. It doesn't stop the bus from continuing on its journey and transmitting the information anywhere else. Okay, so just to add a wee bit more to that then, the bus has the main communications channel. It's got the terminators at each end to catch stray signals to stop them interfering and bouncing back in the network. If a peripheral node, if any of the nodes fails, then the whole network is unaffected, but that node is unable to communicate. But if the bus is faulty, the network will be unable to operate. And again, you can go and do a bit more reading to see about how they need to compete to send and receive data. If you just picture this main channel is going to carry all the data, so if there's data already on there, and for instance this this node tries to send data on the network, then it's a bit like turning out into a busy junction. You've got to wait until there's space to put your data onto the network. So that's a bus topology. The next one is a star topology. So you can see again we've got nodes here, the channel again, and it's important to talk about the central node in a star topology. Now again, if you picture this, if the node here had to fail, then there's going to be no effect on any of these other nodes whatsoever. If the communication channel fails, then again, if you picture just cutting this arm, this branch off, then it's going to have absolutely no effect on any of these other devices, any of these other machines attached to it. The only problem with a star topology is where the central node goes down. Now this is how I like to picture a client-server network setup, that these are the servers in the middle here, that could be hubs and switches and so on, but it's just to picture it in your mind that if the server crashes, then the whole network's going to be affected and you'll be unable to send data to any of the nodes in the network. Okay, so we leave it at this. So a peripheral node failure, then there's no effect on the network. Channel failure is only going to disrupt data sending to that node that's connected to it. But if the central node is faulty, then the whole network is affected, and it can be quite congested with traffic. But it's easy to expand this network. Again, some more reading to get a bit more information on this. A ring topology, really simple to draw. Just picture a ring, maybe draw it a bit more neater than this in the final exam, very messy. And if you picture here, the data is all sent in one direction. And if you think, if a node had to fail here, if this node was faulty in any way, then there would be no way for the data to get past that node. Similarly, if this communications channel's failed, there's no way for this node to communicate with the next one. So a ring topology is not great. It can provide a really high speed of data, but it's really prone to being useless with failure. So this one's really easy to describe in the exam, because if a node fails, the whole network down, and if a channel fails, the whole network's down, unless there's some form of bypass included. So full network's down if a node fails, full network's down if a channel fails, because data is sent in the one direction around the network. A mesh topology, you can see here I've just drawn over the ring one, and I've connected up a few of the different nodes together. You can see this one already is going to be a lot more robust than the ring topology, because if we picture this node failing here, well, that doesn't really matter, because the data could be sent down a different channel and reach the node via a different direction, much the way the road system works, in that if roads are closed, there's always alternate routes that you can take. And again, if a channel fails and we remove this channel here, well, we can still communicate via this node by transferring it along different routes. So it's very robust, because there's many routes that data can take to be sent along the network. And you also on that have a fully connected mesh topology, and you can just see the difference there. And the only difference between the two is that a fully connected mesh topology, every node is connected up to every other node, and this would be my schoolboy error that I've made. I should have only drawn a couple of nodes, and it would be much easier for me to draw instead of spending ages drawing all the lines. But you can feel free to check it. Every node is connected up to every other node, so that can be quite expensive to set up with all the wiring required. So just to recap, mesh topology, multiple connections between each node. A fully connected mesh topology is where every node is connected up to every other one, and it's a good protection against failure, because the data is capable of being sent along many different routes in the network. So just to recap there, some questions to think through there. What's the problems we face with node failure and channel failure in each of the different networks? And these are some example questions that will cover the network, as well as drawing and labelling the diagrams of the network as well. The next type of network that we should have maybe talked about when we talked about client-server, because they like to compare these two in the exam, is a peer-to-peer network, and it's very different from client-server. If you look at the diagram here, it's better to picture this in maybe a small business office where they only have a few computer systems, and every workstation has its own local storage devices, no central server working here, although some machines may operate as a print server, a file server and so on. And it's a bit like if you picture all the teachers in school, if a history teacher's off, then we have no access to the resources from the history teacher. And similarly, if this machine in the corner here was our print server and it was faulty, or there was some error with it, then all the machines would be unable to print. There's a few advantages and disadvantages of it. The one advantage is that they do all have their own local storage devices, and they don't have to rely or worry about a server being operational or buying a server. So it's also cheaper to set up than a client-server network, because there's no need to go out and buy expensive file servers and print servers, but they are becoming cheaper as technology advances, and there's no need to go and buy expensive server software as well. And it's easier to set up the operating system, because you don't need to set up the network operating system. There is some quite high profile disadvantage. Because there's no central file storage, you do not have flexible access. The machine you work at must always be the same. A second difficulty, which we don't have to worry about in school, is that we, or our network manager, looks after the backup strategy that we have in school, and we really just take it for granted. But if we're in peer-to-peer, because there's no central storage, it's much more difficult. Everyone must become responsible for backing up their own data. Like I was saying earlier, if you turn off a certain station, the resources on that station are not going to be available. And it's less secure than client server because every machine potentially may not have to log in. You could set up different accounts on it and so on, but it's typically less secure than a client server network. Couple of different computer systems. Hopefully you remember mainframes from standard grade as well, and they are very powerful computers. They're capable of processing data at very high speed. They can connect up to hundreds of dumb terminals. If you picture the airport, all the terminals that you would go and check in are all dumb, and they're connected up to the airport operating system via mainframe, and they're capable of providing multi-user access. They can multitask. They've got multiple processors. They have got phenomenal amounts of back-end storage and main memory. So all of them connect up to these dumb terminals that only have a keyboard and a screen, which allow people to access and use the power behind the mainframe computer systems. Uses of that rather would be the airport operating system, national lottery computers, and really large companies that have widespread data as well that need to have multi-user access via terminals. So the lottery is a very good example to think of here, that you buy a lottery ticket at a certain store and all of that information is going to be saved in a mainframe computer system, all the ticket information. A larger, more powerful computer system than that is a supercomputer, and we use these to do really intense mathematical calculations. So some of the uses would be predicting weather, for instance, and used in aerospace engineering for modelling different situations that may occur and planning out huge mathematical complex situations that go along with flight, etc. And you can do a bit of reading names, see that they've got tons and millions of parallel processors and so on. Last wee technological bit is we need to know about hubs, switchers and routers. And these are all devices that allow connections of workstations to create network topologies. And the first thing we need to know about is what a repeater is. Now a repeater is simply something that takes a signal and amplifies it, and hopefully that diagram you can see this terrible drawing of a wave is being amplified, and the signal's coming into the left hand side of the repeater and coming out the other side, and it's stronger, so it repeats the signal on. And a hub, all its job is to do is to receive the signal, and it repeats it on to every node connected on the network. So it's a bit wasteful, causes a lot of unnecessary traffic in a network because often signals are not meant for every node on the network. So the hub's good because it can allow us to set up and connect with several different devices on the network, but it broadcasts onto everyone, causing a lot of unnecessary traffic. A better device to use would be a switch, which is like a smart hub, and that allows the full bandwidth to be allocated to the machines that's trying to access it, rather than splitting it up evenly if the nodes on the network, if the machines in the network are not trying to use it. So it cuts down on a lot of unnecessary network traffic. So those are both methods of connecting up within networks. What we use to connect two different networks together is a router. So we can link up two or more different networks. If you think a router in your house is used to connect up your home network and the machines in your home network and the internet, and it's a bit like a route planner in that it is intelligent to plan out the best route that data should take when it's broadcasting to the correct location. Again, these are three things that would be worth having a good read over, looking at the past paper questions to see the type of things you get asked on them. The last wee bit, I hope, is all revision for us. So we've got these different servers here: file server, web server, print server, mail server, database server, CD-ROM server, and you should have a read and understand the different functions that they provide. So it is on here, so I'm just going to go through it quickly, but feel free to pause the screen and have a read at the different things that they cover, and they do like to ask about them. Intranet, which again should be a reminder, is an internal network for an agency or a school, so we have an intranet page within the school. An internetwork, connecting up two or more LANs, again, very simple things that you should just go and have a read over to be confident in. Why do we use computer networks is an important question that always arises in the higher exam. It's much cheaper, first of all, to set up networks. It used to be quite expensive to buy all the devices and so on that we need, but if you think the file servers, print servers, web servers, network operating systems, server software is all becoming cheaper, we can share peripherals, so there is a monetary saving theme behind it, because if we share peripherals in a network, it means we don't have to buy one for every computer system. Companies are spread all over the place now, and they need to be able to communicate and share data with one another, and they need up-to-date information, so it's a case of we've got to have it now. It's not a choice any longer. Last wee bit on computer acts again should be the vision, and you can see the names of the 3 acts that you're going to be quizzed on. Start off with the Data Protection Act. You need to know some of the rights that you would have as a data user, and you have the right to see your information, although you're not always allowed to see it because of matters of national security and so on. You have the right to compensation if the act's broken. You have the right to ask for your data to be changed if you feel it's incorrect. And there's several other rights you have. Companies have responsibilities to make sure it's up to date, that it's accurate, take measures to ensure it being lost, or measures to protect it from hackers and so on, and to not transfer it outside the EU. There's loads of different responsibilities that they have. And again, some reading here to brush up on those. Computer Misuse Act, very simple, 2 things to remember: hacking and creating and distributing viruses. So this Act covers these and sets out how these are crimes. And the Copyright Designs and Patents Act has probably been broken by everyone at some point, so downloading images from Google, as you can see on this one here, this iStock photo that I've borrowed, and I have asked for permission to use that there, maybe, and it makes it a crime to try and then sell that work on to others and pass it off as your own and try and make money from it.